Good afternoon, everyone, and welcome to one of our final parallel sessions. I am delighted to welcome Fiona Carroll today. Fiona is going to be talking about building towards a more inclusive computing learning experience. She'll talk for about 20 minutes and we'll have time for questions at the end, so add those to the comments. And without any further delay, I want to hand over to Fiona. Thank you very much.
Thank you. Hello, everybody. As nicely introduced, I'm Dr. Fiona Carroll, and I'm from Cardiff Metropolitan University in South Wales, where I am currently a reader in human-computer interaction. And I'm going to present some work we did at the start of the summer around looking at more inclusive computing learning experiences. So I had a small team, and I know Romana is in the audience, who went out to schools during, as I said, the start of the summer. So we're going to give you a bit of a snapshot of this research and project in this presentation. So just to give you a quick feel, I'll give you a background to the project, and then our motivation really from a Welsh perspective, a UK, and then a global perspective. I'm going to talk briefly on inclusive education and in particular engaging girls in STEM. Then I'm going to zone in, talk about the project, share with you some of the examples from the work that was created, and then very briefly talk about our plan of action for the future. So the project was an aesthetic programming research project. Now, I suppose the first thing that would come to mind is, what do we mean by aesthetic? And it's very much about tapping into the senses. So we were looking mainly at visual properties and the coding of visual properties to tap into people's intuitions and emotions, and that was the angle we came at. It was very much a design problem-solving activity, and we were looking at, using new aesthetic, well, not so much new aesthetic, looking at aesthetic techniques and creating aesthetic experiences through code. And that was kind of the channel we chose to try and engage the children in programming. So it was funded by Cardiff Metropolitan University. It was an internal pot of money, and that enabled us to hire 3 of our own female student facilitators, or female students as facilitators. We had 1 female researcher, Romana, that I made reference to earlier, and then myself looking at it from the academic perspective. We visited 10 schools in South Wales, and we delivered 20 sessions. So it was quite an interesting time, because it was that period as schools were coming out of some of the strict COVID restrictions. So we did dabble with the idea of doing some online sessions, but luckily we managed to get in and do 20 face-to-face. So this was also in partnership with First Campus. First Campus is a HEFU-funded Reaching Wider project that's running in South Wales. So that's just a brief background to the project. Now, our motivation, I don't know if any of you are familiar. I'm guessing you have heard somewhat of the gender gap in STEM. This has been on our airwaves for over 20 years. I myself have been working in HE for 18, 19 years, working in schools of computing and maths, School of Now Technologies, and there is still a gender gap. So with all the talk that's been going on, and with all the different projects through the years on the ground as an academic, I am still seeing, very few females coming through. And I suppose I'd have to add, even though we were looking at engaging more girls, we were very much about, creating this image of computing as a gender neutral. So we're interested in engaging all genders in computing, because at the moment it is very one-sided. And the HESA 2020 figures, student enrollments in HE and computer science in 2018, 2019, you've got 20,000 females versus 93,000 male. A British Computing Society report 2020 is showing that the level of female representation in IT varies, as you'd expect, nation, region, but at its highest in Wales in particular, we're looking at women accounted for just 21% of IT professionals, or specialists, sorry. So, it's still an issue. And just interestingly, some of the research shows if the UK alone equalised the labour market, there could be, huge economic benefit. Looking in Wales, again, in particular, the IT sector employs 45,000 people. That's worth over 8 billion a year. So if we could equalize that labour market, again, for the Welsh economy, it would be big news. So looking at it from a UK perspective, 18% of girls in tertiary education are pursuing STEM compared to 35%. Girls are saying that they're put off a career in tech because it's too male dominated. So it's like this chicken and egg scenario, really. Only 22% can name a famous female working in tech because they're clearly in the minority. Looking at it from a wider perspective, research is showing that girls' interest in computing drops early during primary and secondary education with minimal recovery. So that was, a big rationale for us to go in and target year 4, year 5, and year 6, which we did. And there's many different, as I said, this has been the talk for the last 20 years. As long as I've been in HE schools of computing, this has been the talk. So there's been lots of research done, and lots of reasons found. Some of them are tied with that gender science stereotype, and 2019 research has shown if we can create this less pronounced masculine image of science, or computer science even, there's a potential, a likelihood to increase the number of girls entering into STEM, but also we have a knock-on effect. Lang, Fisher, Craig 2020 et al. Are showing that girls, their lack of engagement in school, as naturally we would expect, is having a knock-on effect on the workforce. Girls are not seeing value in computing. So there's reams. I could go on in terms of what research has shown over the years. And there is work, as I said, there's lots of projects happening. Dr. Alison Scott, who leads the Kapoor Centre, is just one of many projects in the States, and they're focusing their research on access and opportunity, investing in community or organizations, and gap closing, social ventures. So they're going out into the community, and within that community, they are looking at, role models is a big area that lots of people have looked at, and also breaking that geek culture. The geek culture undermines women's interest and confidence in computing. A lot, again, lots of research there. Very few females desire to achieve geek status. Now, I know this is a kind of a sweeping statement, but again, overall, when you look at the stats, the girls are not coming through, are not interested in pursuing their education further within computer science or even in the workplace. And just to finally round up, how do we engage girls? And, taster sessions, for example, that's something that we do at Cardiff Met. Setting up role models, I think it's really crucial. Like, one of the reasons we chose 3 female student facilitators to work with us is that we wanted to increase that exposure to the female role model in STEM, in computer science. Support teacher training. And also another area that I know a lot of work, I've read some research and success, showing success stories, particularly coming out of the States, where they look at dual degree programs. Again, at Cardiff Met, we've got creative computing with creative design, program where we make links with the School of Art and Design. So it's this idea that this cross of disciplines might be a good way to get more girls in. The program has been running 3 years now, and I would say that our numbers are low, but there are a good balance between the girls and the boys within that. So looking at that, that backdrop of 20 years or so research, as I said, on the ground, we've still got an issue. And over COVID, I started to think about my own, relationship with programming. And I started really to look at when you start to learn programming, the problems, the textbook problems that you work through. And I started to think about, well, if we start to look at the problem and change the problem, if it becomes more of a design problem, how things look, does that look good? Does it look, how can you change the appearance of something, tapping into the senses? How do you code something that, our character, for example, that's happy or that's serious, that's sad, and started to kind of explore that avenue. And at the time, I started to explore JavaScript, and that's what we looked at with these school kids, P5 JavaScript. And we designed, a lesson plan combining narrative, design, and code to stimulate the children's curiosity and to engage them, hopefully, and make connections for them. So the emphasis was very much on that, the design, but through their desire to improve the design, they naturally were getting more and more into the code. We had 466 Welsh primary school pupils from years 4, 5, and 6. And as I said earlier, we had 10 schools that we worked with. Before the lesson was just under 2 hours, and we had a pre and post lesson activity questionnaire just to kind of probe the kids around their impressions of programming before and after. So the questionnaire, just a snapshot there, was quite visual, and we were interested, questions like, what 5 words would you choose to describe computer programming? So before the lesson and after, how would you describe the computer programming to a friend? So really just to kind of get their feelings around it, and then also probe them, what do they think a job in computing would be like, and kind of tease out some of their thoughts around, programming as a career. So just to give you a sample, we gave them a very open kind of brief. Like, imagine you lived in a big castle, your parents are renovating, and you've got the chance to decorate your own room. Okay, so the constraint that they have is that the patterns within the design, within the wallpaper, for example, that they're designing, needs to be geometric. So straight off, they've kind of got this scenario, and we then exposed them to lots of different types of geometric patterns, and we looked at linear. We drew in from some of their maths lessons around linear symmetry, radial symmetry, geometric shapes, and we looked at existing patterns. We had quite a few graphics on different wallpapers with geometric patterns. So we had a discussion really just to inspire their thoughts. And then we started to slowly introduce the coding. And that was very much, we had a cheat sheet. So starting off, getting them to code the basic geometric shapes. For example, code a square and then color the square and look at coloring that square. And we really tied it into, even, the explanation of the web editor that we were using for P5. We gave them the scenario that, if you were an artist, you need a canvas and you need, your drawing materials. And we explained this is your canvas in P5. And this is how, your drawing materials is your code, and this is how you draw a square, etc. So it was a step-by-step process to take them through, hand feed them through the basic shapes. But then once they got familiar with that, then it was allowing them to explore. This first session, a lot of the kids had never programmed before, and it was really allowing them the space to just draw with code. This is our P5 web editor, and the syntax in the code, looking at back over the 466, there's quite a few errors, but the emphasis here was very much just exposing them. We were looking for that kind of engagement hook, really. And then the analytical will come, like at the end, quite a few kids, they might aim to draw a circle, for example, and the circle wasn't appearing. So then, we would encourage them to go back in and look at their snippet of code, in a more analytical fashion. Well, what are you missing? Compare it to what we've got up on the board. And just to give you an idea of some of the, as I said, some of these kids had never programmed before, and it was less than a 2-hour session. And they were really, in terms of creativity, they were really starting to impress us, really, in terms of the designs. And as you can see, that they're quite different, which was really nice to see as well. So just to recap, we had 215 male pupils, 188 female. We had 13 pupils who preferred not to say, and 10 other. So we had, quite a number of kids run through these lessons. So before the lesson, a lot of the kids were very excited just to have us in. I think after COVID, it was something novel. But it was nice to see that both male and female, there is a slight, difference in that more males felt that they would like programming compared to female, but there wasn't too much of a difference there. And likewise, before the lesson, male and female found programming to be interesting. So that coming into the lesson, there was quite a positive feel. And this is just to give you a quick snapshot of the before and after, really. So the before lesson, you can see, fun, hard, cool, exciting, confusing, but in, the headlining topics that are getting most hits, would be fun, hard, cool. And then you have more coming through. I think in the after, you've got the fun, hard, cool there, but you've also got nice, fun, good, boring, helpful, amazing, exciting, confusing, funny. So it's I think they, after the lesson, like anything, they're after the experience. So there was more vocabulary there, possibly to describe the experience. Before the lesson, again, how would you describe computer programming to a friend? And we have like, make, coding, can, think, will. And it was interesting to, obviously, I've just, again, taken a quick snapshot, but a lot of the kids kind of linked it into their, as they would, to their own, what do they know about computers? And it's generally games, you know, like it's like creating a board game, but technology and a bit more complicated. It's confusing and you got to do coding and hard stuff, but I think it will probably be cool. It is an online thing to make, like anything, just by coding. Computer programming is hard and sometimes easy. At the same time, it can get confusing. You know, so that was kind of the general feel coming through before. Afterwards, we've got fun, cool, easy, interesting shapes, aesthetic, you know, so we've got almost a richer selection of vocabulary coming through. And what was coming through in the qualitative was very much, it's just coding. It's really complicated, but it's really fun. You just have to understand it. When you get the hang of it, it's amazing. Fun and interesting. You just have to do it to understand. Quite fun. I would tell you, try it out. It is so much fun. You can make anything you want. When you are sad, I would volunteer for you to go on this website. It will make your day and make you happy. So the feel is that it's not a walk in the park. There's still challenges, but it's like, you know, it's worth persevering with, because once you kind of get the hang of the syntax, you have that direct output. You've got the shapes coming through. So I'm just conscious of the time there. So where are we now? So we've come through the summer and we're still looking at the data. But it was overall a very positive experience. It was really nice to see, you know, all the class, no matter what gender we were looking at, engage. Now, I'm not saying that all 466 kids will become computer scientists, but it was that the hook of engagement that we were after. And I think, you know, from observing the classes and working with the kids, that's definitely started to come through. So first phase was about drawing with code, and we're hoping now to develop with First Campus, to continue with First Campus, to go back in and start to look at, you know, some of the building blocks of programming. They've had the exposure. They might need, you know, a few more sessions, you know, just enjoying that drawing. And then we start to come in with, you know, similarly designed lesson plans, but looking at things like variables, functions, conditions. So some of those, as I said, building blocks or fundamentals of programming. So future plans for us, as I say, get back into the primary schools along with First Campus, but also within our own HE setting. It would be good to mentor and coach some more female student facilitators, and to, you know, build their confidence as role models, and, you know, bring those girls back out into the schools, and hopefully inspire some of the younger girls coming through. And I think that is it from me. I'll stop sharing my screen now. So if anybody has any questions.
Hi, Fiona. I would just like to say that there hasn't been a vast number of questions, but I would just like to say how interesting I found it, because my daughter is at that age now where she's going to school and she's having science lessons. And I was so interested when you were talking about the breaking that link to geekiness, because that's exactly what it is. It's rooms full of boys talking about, like getting into code and doing all this stuff that's really kind of, like you say, quite brutal and a little bit. And the approach that you were discussing, where you're taking it around the other way, where you're finding out what people want to do and then working out how to do it, rather than just diving straight into the code and saying, this is the code, learn this for an X period of time, and then you can go away and do these things with it. But it's focusing on those, practical hands-on approach that I found fascinating and really excellent to listen to. So I just thought I'd say that at the end there.
Thank you very much, Jenny. It was very interesting to be in the classroom, and the conversations were, wow, well, how do you make that look better? Like, what color schemes would you, and like, in order to achieve that, they are in the code, because that's how they draw it. And it was very much like, look what I created. And then it's like pushing it's a design problem, really, but it's using that to engage them. And it was really nice to experience that and that buzz around coding.
I mean, I guess that reclaiming that kind of coding from its bad reputation is going to be like you were saying about getting future ambassadors building up so they can go ahead. It's going to be a time-consuming business, but it's a great way to start. Anyway, just thought I'd say that. No, thank you very much. Well, I think that's about it for us today. So we'll say goodbye, or Carol can say goodbye. I'll say goodbye from butting in. So goodbye.
Thank you. Bye-bye.